Do you feel like you're late to the game on the Coyote? Because you know, you see, Texas Speed just got into the Coyote, right? Mm-hmm. You know, Boyd, a couple guys, Boyd and Barris just tested it on his Coyote, and with Texas Speed Block, you know, you have other guys, FFRE, TKM. Those guys been pushing the Coyotes crazy. Do you think you're late to the game on that, or?
I mean, could have we started building Coyotes sooner? For sure. Have we devoted all of our time and effort into one platform and learned a hell of a lot? Yes. Prior to late model engines, I built a shitload of 4-valve, you know, the mod motors, right? So I've got hundreds of mod motors under my belt, and you know, we've got a couple guys internally here that on the team that are very much into Coyote engines. So we've been building a few over the years just as a default. You know, we have a good customer that says, hey, we usually build them LS engines and they've got a Coyote or they've got a whatever to build. We do that and, you know, build a kind of a one-off. So might be late to the game, but you know, I wouldn't count us out by any means. It's all awesome, it's all airflow, like we were just saying, right? Yeah.
Thank you for watching Go Hard Podcast. I'm your host, Noel. Guys, we're out here. We're at LME, one of the best engine shops in Houston. Could you say that?
I would definitely say that.
Nice. So we're out here. Took us like an hour to get here. Weather's bad in Houston. If you know, you know. It is May 16th. But if you're driving around, maybe you're parked on the side, crazy weather right now. We talked a little bit at Texas 2K about doing the podcast. They said they were all up for it. If you're watching the channel, if you're new to the channel, make sure you subscribe, hit that follow button, and put in the comments who you guys want on the next podcast. On this podcast, we're going to talk about, you know, the engines we have back here, the billet blocks, you know, the iron blocks, all the builds that they do, what's new to come for them, the new parts they got, you know, the production side of LME. We are going to discuss, you know, I don't know. I haven't seen a Coyote block on their page. Maybe they're going to start offering Coyote blocks, but we will find out on this podcast. So who do I have pleasure speaking with today?
My name is Brian Nealon. I'm a co-owner of Late Model Engines, and operate this with 24 employees.
Wow.
I've been around since 2003.
I seen y'all started posting in 2013 on Instagram. Mm-hmm. Is that when y'all started getting into the social media side?
Yeah, just kind of starting that whole thing. I mean, for the longest time, just going strong with, you know, local and shipping stuff out of state. We did some advertising in magazines and that type of thing, but really just got into social media around 13, yeah.
Okay, so we're gonna hit it off slow, guys. We're gonna just start with the basic questions, then we're gonna ramp it up like usual, you know? If you've been following podcasts, you know how I usually do this. Who and it's you and who else owning the
Pecos Laughlin is my business partner. We've been together doing late model engines since 2003, since the beginning. So we started our business based off of the lack of CNC machining in Houston. So we're young, getting into the game. Both working at machine shops, building engines in town, and you know we went to the school of automotive machinists, Sam Tech now. Okay. Yeah, so that's where we met. We started doing some cylinder head porting by hand porting cylinder heads after hours, kind of moonlighting, selling stuff on eBay. That was when eBay was starting coming around, and just saw the need for. Since we were young, the guys that we were working with were older. They weren't willing to invest in the machinery that was needed to really go the long distance in this industry. So our recognition of needing the CNCs to keep up with production and to, you know, be able to, you know, machine in a modern fashion. So we got into the CNC equipment together, and that was really kind of like what propelled us to move forward.
So did you start with like a Dremel?
Yeah, it's a Milwaukee grinder. If you're a head porter, you know it's a pretty nasty electric grinder. That's what everybody's using at the school, and that's what we learned on. But yeah, so you just go to town, lay it all out, map out your ports, lay it out, and then just get busy by hand. So usually you'll have about let's see, about 30 some odd hours in a set of heads. Here we're porting a few sets of heads a day with multiple machines and all of that. So it's quite a difference.
So could you say for those out there that are starting out, right?
Yeah.
Just to get into porting, they're using the Dremels or whatnot.
Sure.
You're not really sufficient doing that type of work because you're not precise with every, like when you get a head, you're not that precise on the next head because you might cut more, cut less.
You can be very precise by hand, but you can't over time be as consistent, right? So you can do one port. You can do a whole cylinder head, but the consistency from cylinder head to cylinder head will suffer. But the CNC is, if you're just starting out, you're better off to be able to port by hand and then move to CNC than just never picking up a grinder and trying to port heads with a CNC. You know what I mean?
Why is that?
So it's the development of the port, right? And we've evolved, here at Late Model Engines, we now draw the ports 100% on computer. We will hand grind and do some digitizing, at some points in the process. But a lot of guys starting out, they'll hand grind the port, then digitize and CNC, right? What we're doing right now is we're drawing the port in SolidWorks, or we have a couple different programs, but primarily SolidWorks. We're drawing these programs, drawing the ports, getting our surfaces, putting toolpath on that, and then we can make rapid changes as opposed to going in and hand grinding, testing. We can move the process forward a lot more quickly.
Nice. Can you tell us when you started getting into the shop, how did you start, at a garage? Most people start their automotive careers in their garage,
Yep.
and then they go from garage to shop, and then shop, then they grow more and more and more.
Sure. So really the beginning of my career in this was a buddy of mine. We moved from New York down to Texas to go to Samtech. We used to work on his car. That was kind of our common bond. We worked on his Camaro and was always into cars, racing, all of that. And so decided to come down to Texas, build race engines at the school. That's where ultimately I met Pecos Laughlin, our business partner. And, the rest is history type of thing. We like I said, we started on a little small shop, little 2,500 square foot shop that progressed to a 5,000 square foot shop. I worked for another machine shop for about a little over 4 years, building all types of race engines, even, anything from like a Willis Jeep to a, big block with nitrous.
Nice.
Lots of circle track race engines. There's a lot of dirt and asphalt late models in Texas, a lot of that stuff. So we ran the whole gamut over there. And like I said, we started porting cylinder heads at night, selling those, gaining a little steam, bought some first pieces of equipment, and just kept going along. So after about 3 years of doing that, decided to make it the full-time gig, and then so it was just us building engines, both Pecos and myself, and then we brought in our first employee and kind of started building the team from there.
And Sam Houston, is that the tuning school?
No, it originally was called Sam School of Automotive Machinists. Now it's called Sam Tech. And it's in school devoted just for race engine machining and theory. So you'll have class time,
right.
Talking about the inner workings of the engine, airflow, whatnot, and then actual class time where you're physically machining the engine blocks, cylinder heads, and assembling, dyno testing.
So your experience going to school, then actually right here having a shop building engines, could you say that going to school helped you get to this point? Or because, they have some guys out there, they're like, oh no, I don't want to go to school, right? My grandpa or my dad taught me how to build
Sure.
engines. Can you speak on the importance of that?
I think you can definitely do it both ways, right? There's no doubt. You can be self-taught. You can learn from others. I think going to the school benefited myself just because it threw me right into the mix of, being in an automotive machine shop, actively building and testing race engines. Kind of it accelerates. It puts you full time into that mindset of, it's all we did was eat, sleep. Well, that's all we do now anyway. You know what I mean? But
Yeah.
it was all race engines all day and all night. So you meet a lot of good people. I mean, it's networking. So there's definitely benefits for
Right.
going to school as opposed to just kind of learning on your own. Get to see some techniques and ideas that you might not be exposed to if you kind of just stay within your own bubble,
Right.
Yeah.
Yeah, I know. You see those guys, especially the Facebook guys, are like, oh no, I built this out of my garage, or or I learned this, I learned that. But I think the networking when it comes to schooling is, I think, the biggest you get from that.
For sure. I mean, we've got friends that we still talk with in the industry today. They've gone off and done their own thing, been a part of different forms of racing. So now we have friends in import racing, in NASCAR, Pro Stock, Top Fuel, whatever it may be.
Mm-hmm.
So now you have that network of, you're saying, hey, we're seeing this, we're seeing that. What have you seen? It kind of pertains to your niche of racing,
Right.
So that's.
Or you see them like on you follow up on them like on LS1 Tech, or
Yep.
you see them on like on those forums and stuff.
Yeah, I mean, it's when you're not exposed to a lot of different things. I mean, you kind of get potentially, shoehorned into your own, which you don't know type of thing.
So, is this the first shop you start? I mean, your second shop,
It's physical location.
right? Is this your
Yep.
second location?
It's a second location. So the first location when we were brand new, it was 2,500 square feet. Then we busted a hole in that thing. It was one of the, like a strip building. Acquired the 2,500 square foot next to us. So then we were 5,000 and filled that thing to the brim, busting out of the seams there. And then we were there for 15 years, right? And then moved over here. And our current facility is 17,000, a little over 17,000 square foot, the one we're in now. So huge step
Yeah,
up
for
in
sure.
square footage, and we're about to blow the seams out of this thing. So I'll show you later on, but yeah, we're getting packed up in here too.
No, it's packed. Guys, I tell you, if you come to this shop, man, this is like kid in a candy store for some, some guys, like, for real. They have engines galore, intakes galore. That looks like a Plasma Man engine. I don't know why. Like, when I seen it right now, it's just.
Come on now.
No, when I just seen it right now, and that's what I thought of,
Right.
Okay. But they got. I mean, can somebody just walk in the door and get an engine? Like,
Yeah, no doubt. We get quite a few walk-ins, just from Houston. I mean, we're fortunate to be in Houston because we have such a great local clientele, and the action is so good, right? Some shops are, there's just not much going on in the racing scene in general. I mean, Houston's awesome for that.
Yeah.
So we get quite a few walk-ins. I mean, tons of shops in town. So a majority of our day-to-day business is B2B. I mean, it's business to business. So you drop your Corvette off of, any shop around in the nation, they call us up and we'll supply them with the partial, complete engine, cylinder heads, whatever they might need. But we definitely have a great following here in town, and, it's awesome.
Yeah, especially, now that you're saying that, and, what about, Texas 2K was a big part of, I know it's in Dallas now.
Right.
And before, I seen a post. Someone blew their engine at Texas 2K, but it was when it was in Houston. Mm-hmm. And I think they swapped out the engine. Y'all gave him another, maybe it was just short block.
I think that happens every year. So no, we had a couple gentlemen drive down from Dallas this year. We fixed their cylinder head.
Really?
It was same day deal. But the prior year, I think the same thing happened.
It was that good, yeah.
Yeah. So they torched a cylinder head.
It's on a Corvette, right? C7?
I think so.
Yeah.
I think so.
Yeah.
But yeah, they drove down and we hooked them up and just made it happen type of thing, That's just racing.
Yeah.
Everybody, help each other out type of deal.
Are pretty hectic at that time around?
There's always the rush. There's always TX2K rush for sure. I mean, there's somebody that either didn't plan properly or something happens just before the weekend.
Yeah.
They're testing, trying to make power, trying to do whatever. So yeah, there's always a couple things going on.
Yeah.
We leave a little space open.
So how is it? So can somebody walk in the room, walk through the door, order an engine, or is everything online? And I know you said that you work with bigger shops. I mean, you work with shops.
Sure.
And so, or do you work with the customer? Like
100% work with the customer. So what's on our website is really a small fraction of what we could offer. I mean, with these engines, there's so many, almost infinite amount of combinations. Right. What we have on our website is what we've found to be our proven go-to combinations for a given power level, budget. So that's what we're going to try to go towards, but that's what what's on our website is all of our custom engines that have progressed into proven packages. So you can start there. If there's somebody looking to do, like a more of a pro road race type application, we're going to build something that's specific for that. If they're looking to run, a drag race combination or a half mile combinations, we're going to set that all up. And one of the benefits of all the people that we have in our facility, on our team, is taking all of that knowledge from the different forms of racing that we've been involved in and tailoring that. So it's not like we're just drag race guys, we're just road race guys. We're using everything to build, the perfect combination for that guy's application.
What is your top, sales right now? If you can say, maybe it's like a certain short block, maybe it's your intakes. Maybe
LT for sure. So,
LT?
Yeah, we've definitely surpassed more. We're building more LT based engines than LS, right? And that actually happened about a year or two ago. It's right there. I mean, we're building a ton of each, but that's our most popular. I mean, like if you were to pick one, probably a 416 LT1, LT4.
Nice.
For, 10.5 to 1 for 1,400 horsepower. That's our you can't go wrong with
bread
that.
And butter right
That's
there.
Bread and butter right there.
Guys, we're talking about the new LTs, not the LTs in 1990s. Just to clarify that.
That's right.
Because a lot of guys mistaken that, honestly. Mm-hmm. Especially if you don't put it, they think you're talking about the
right.
The older ones.
That's right.
But
direct injection.
Direct injection. The DI1.
Yeah.
Can you tell us, when it comes to the LT, and I've spoken to other Chevy guys, tuners, and they said that Chevy messed up not giving us both direct injection and fuel injection. Could you agree on that? Or what?
Direct import, you're saying?
Direct import, I'm sorry.
Yeah.
Yes.
Well, I mean, I guess they only did one time with the LT5, right?
Right.
And then, so, yeah, I mean, that would be a game changer if all of these LT cars, if like your ZL1 Camaro came with port and DI, it would be sick, right? I mean, that would the cost of modifying would be much less, right? Because that's one of the hardest aspects of modifying a direct injection LT is the cost of the fuel system. That's like compared to an LS, right? If let's say you're doing a swap, and you want to make 1,500 horsepower, the fuel system for the LS is a lot more straightforward as opposed to buying, if you're going to go LT and then go direct injection and supplement with port injection. It's like, it's over double the cost.
You're right.
So, yeah, I mean, the GM would have been helping out the racers for if they set everything up with, like if the LT4 as opposed to the LT5, the LT4 had port, that would be killer.
Yeah.
So, but it doesn't.
I feel like that's the breaking point of people, not people, of the ones modifying their cars, I mean, they're like, oh no, the fuel system's, nah.
Yeah, I mean, that's the limiting factor, and that's something that you obviously can't cheap out on. You know, I mean, everybody that cheaps out on the fuel system, then now you spend all this money on an engine and you're doing it again, right? Yeah. And then you got to buy the fuel system because now you learned your lesson. Yeah. So yeah, fuel systems can get a little costly, but it's necessary.
Any new products?
Our newest stuff is the billet blocks. That's our I mean, that's an undertaking. You know, when we first started that project, you're like, oh, you know, this won't be that bad, and it's not that it's that bad. It's just a lot. It's a lot of tool paths. It's a lot of things to work out. But it's coming along really, really well. We have a unique design on the water jacket design. So we have a water jacket system, water jacket design that's like nothing else on the market. We're in the testing phase of that. So as soon as that's thoroughly tested, we're going to be offering it, and kind of more widespread. And that's something that we can adapt to any engine platform. You know, whether it be a big block Chevy or a whatever, right?
Right.
So that's something that's been in the works for quite a while, and we think that it's going to be a great alternative to what's currently out there.
Is that a different machine for you making the billet block, creating the billet block?
It's all the same principles. We're doing this in a horizontal machine. Most of our other machines are vertical CNCs. I'll show you later, but just a different way of different approach to machining, okay, but all the same principles in a sense.
Got you.
Yeah, so it's right in our wheelhouse of what we've been doing. It's just a little bit. Just more chips.
Right. Can you speak on the importance of running the unique design of the water jackets? Because I know on some, for those that are watching out there, it pretty much the billet block. So what you're saying is pretty much the billet block it corresponds to the iron block that they have when they're running they're using their factory cooling system.
Right. So the goal with the billet block, with a water cooled billet block, is to have the water capacity, yet still retain the strength needed to handle the cylinder pressure.
Right.
Right. So it's a trade-off. You either have more material behind the sleeve and less water, or you have more water and less material, and that's where your strength trade-off is going to be, from cooling capacity to structural integrity.
Right.
So our design, we feel, is the best of both worlds of that. The way that we're machining the block and our whole setup there. That's kind of where we're at with that.
But you can still, because in the racing world, they're going billet. Some guys they go full alcohol,
right, on
billet block, but they're not keeping the factory cooling system. But so you're saying with your design,
right?
You can keep it.
You can keep it. So a big part of our business is high horsepower street cars, or high horsepower cars that can be driven on the street, right? So if you're or an endurance application, road race, whatever it may be. Whatever you're trying to do that requires you to run longer than a quarter mile, eighth, quarter, or half mile, you're going to need to have water in the block, right? Mm-hmm. And so if we're just going straight drag racing, running methanol, there's no need to have a water-cooled block. You are better off to have a well, some could argue that too, but it's stronger. You have a stronger block if you don't have a water jacket behind the sleeve.
Right.
That's the biggest thing that guys need to know when they are looking at a block that is sleeved. An LS sleeve production block is not a great way to go if you have an alternative as a billet. The reason being is that there's not enough material behind the sleeve to support it, right? So if you have, our billet race block has a little over 400 thousandths of material behind the sleeve. And then you have, say, like a 75 thousandths thick sleeve. Well, if you have, say, 100 thousandths thick sleeve and then 75 thousandths of aluminum or less, because you have a casting and it's going to be inconsistent, or that's just not designed to take that larger OD sleeve, there's over time the sleeve is going to deform, and you're going to have decreased ring seal, more blow by. It's just going to not be strong for long, right? A sleeve block. Looking at the Coyote stuff, a little bit different than an LS or an LT. So sleeving, and we all know that Coyote blocks are being very successful with the sleeving process on a production block, right? Mm-hmm. That same concept has been done forever in LS and LT, and in some applications we have to do it, and we know what we're working with, so it is what it is. But the difference between a billet aluminum block that's made to have optimized for material behind the sleeve compared to a sleeve production block, it's just not even in the same ballpark.
Yeah.
And that's a big reason why it's the amount of material behind the sleeve. That's huge.
Have you opened up a Coyote engine?
We've been playing with a few. So we're in the development stages of a couple projects with that. We've got a couple guys spearheading that internally, and
they're very different engines, right?
Sure.
One's pushrod, one's driven by dual overhead cams, right? What are the pros and cons of the Coyote and the LT?
Well, I'd say that some of the inherent pros of the Coyote, I mean, RPM valve train is huge. I mean, the cylinder heads move a ton of air. So I mean, you've got a lot of potential there. I mean, engines making horsepower is airflow,
right?
And you've got a lot of valve surface area, both on the intake and exhaust, being 4 valves per cylinder. The ports are extremely efficient, and then you have a very stable valve train, obviously, because you're taking the push rod out of it. I mean, it's just inherently different structure, and you can obviously turn a ton of RPM with a dual overhead cam. So those are definitely pros. The LS, I'd say one of the pros of that is just sheer size, cubic inches, right? Mm-hmm. If you have 2 engines and you can move the airflow on, you can move sufficient airflow on both, mm-hmm. And turn the RPM, theoretically the bigger engine is gonna, it's gonna make more power ultimately. That's not everything, but so we're based, and like I say, our heart's always been with the LS. That's what got us going in this whole late model mm-hmm. engines. That was our flagship. That is our flagship mm-hmm. power plant. We do the LT as well, but we're into horsepower regardless. So if it makes power, it hauls ass, and it's an engine. I mean, we're into it. We're not really partial of Ford, Chevy, Chrysler, whatever. I mean, if it makes power and it's an engine, quality engine, we're all about it.
That's awesome, because especially you're not sticking to one. You're not holding the flag for it, and I feel like this might be controversial, but I feel like a lot of people they stick to one thing.
Yeah.
They don't adapt to modern technology. So, and especially in business, whenever you have to adapt
100%.
with your business, right?
100%. Yeah. I mean, I think it's kind of silly or naive to think that one thing is just the end all be all of the game, right? There's always going to be the next thing out, and we're late model engines. We're all about what's the new thing coming out, right? Now we're on to the LT2, right? We got billet blocks for an LT2. Mm-hmm. Can't even tune the damn things barely. You know what I mean? So it's like, we're trying to be on the forefront, and like I said, we just love horsepower. If it makes power, we're into it.
Do you feel like you're late to the game on the Coyote? Because you see, Texas Speed just got into the Coyote, right? Mm-hmm. Boyd, a couple guys, Boyd and Barris just tested it on his Coyote, and with Texas Speed Block, you have other guys, FFRE, TKM. Those guys been pushing the Coyotes crazy. Do you think you're late to the game on that, or?
I mean, could have we started building Coyotes sooner? For sure. Have we devoted all of our time and effort into one platform and learned a hell of a lot? Yes. Prior to late model engines, I built a shitload of 4 valve, the mod motors, right? So I've got hundreds of mod motors under my belt, and we've got a couple guys internally here that on the team that are very much into Coyote engines. So we've been building a few over the years just as a default. We have a good customer that says, hey, we usually build them LS engines, and they've got a Coyote or they've got a whatever to build. We do that and, build a kind of a one-off. So might be late to the game, but I wouldn't count us out by any means. It's all
awesome,
it's all airflow, like we
Yeah.
were just saying, right?
Yeah.
So you apply the same principles to a new platform. We have the capabilities of making some products for these things. We already got some good ideas. So trying to just isolate issues with the platform or like weak points, I guess, build those up and go from there.
Right. And, especially in Houston, you have, I've had many guys on the podcast, Ford guys, Coyote guys, and I'm pretty sure you can give one to one of these short blocks to someone. They can test the crap out of it.
Yeah.
Push the limits to it,
100%.
And yeah, man, is there another company in Houston building short blocks for Coyote?
I'm not sure. I'm not sure if anybody
I don't
else
know.
is like, that's out there on the market that's like regularly known, I mean, there's a couple other machine shops in town here that will build you whatever, but
Yeah.
I'm not sure if anybody.
That's
in town.
awesome, honestly. Because I know I thought of questions before, right? Before
Sure.
doing the podcast, but now thinking about it, like, man, I feel like you're going to,
We've got
once y'all dominate the Coyote engine, I think it's going to go crazy in Houston.
no doubt, man. We want to get some of our stuff out there, get us out in a couple key guys. There's always people that we can test with and all of that. But again, putting all of our equipment and tooling that for the Coyote, I mean, between being able to dyno them if we need to dyno them, we plan on doing a bunch of short blocks, cylinder heads. Casey, he's working on an intake, an exhaust program right now, modeling the ports, to port the cylinder head. That's looking amazing. We're starting to make some valve train components for him, and then going back to the sleeves. So we've been doing a lot of research on that. We have some machinery that I'll show you out there. It's a big hoss of a machine, and
Nice.
thing is gonna like murder some Coyote blocks.
You got to send, I feel like you have to send one to at least 2 guys, I'm going to tell you right now. And they would test the crap out of them. Midnight Performance and Mexico Racing League.
Okay.
And they have a big following, and they're both backed by Lund Tuning on the factory ECU, and those guys would push them, man.
Hell yeah.
But they're gonna give you their honest opinion,
Yeah, I mean, that's where it's at. So
Yeah.
I mean, and that's the only way that you learn.
Yeah.
I mean, you can't go out expect to be the number one with the first engine on the first
Right.
shot and all of that. But like I said, this isn't our first rodeo, as they say.
Yeah. What about the heads on them? Will y'all port those heads too?
Yeah,
Because I know you said right now that and I had other guests on the podcast saying that the heads they flow real awesome already.
They do. So they can move a ton of air. It's really for the guy that's looking to optimize their entire combination. It's same with an LS engine or whatever. You shove 30 pounds of boost down something or whatever, it's going to make some power. But if you're racing a guy that has a stock set of cylinder heads to a guy that has a optimized set of cylinder heads, you're not gonna hang. I mean, it's just I think it's anybody that tells you that more airflow isn't gonna make your engine more efficient. I don't know if I would be following them.
Yeah. I hear you. So what about the will y'all take in factory blocks to like maybe build those as well, or will y'all just make your own casting of the block, or just go?
We're definitely going to
straight
use the factory block, the factory
Okay.
cast block. We plan we have 2 combinations that we're working on right now. It's like a non-sleeved and a sleeve combo, with components to match, right? So those will be available as just for straight up purchase. But if somebody's local or needs to send in their block, they have a block, we can
Right.
hook that up too.
So we're not gonna go too deep into Coyote because first they haven't really released them,
Right.
and then you're not, it's kind of bogus to be. Oh yeah, it can hold 1,500. When it's kind of,
We're not making any claims.
Yeah.
As of right now.
Right.
But seeing what else is out there and our knowledge of that block and that platform so far, I mean, it's all going to be,
Compared, yeah.
be good.
So let's go back to the LT and the LS. The bread and butter.
Yep.
I seen you. You did I did some work on like Vipers.
Yep.
And Dodge.
So over the years, we've done a ton of Vipers for some different guys. We're doing a ton of Hemis right now. So, really, Chevy, Ford, and Chrysler, we've always been in the mix. Been doing Hemis for a real long time. Now with the 6.4, it's really gained a lot of more popularity. We've got some cool products for that.
They do a lot of Hellcat. Y'all get a lot of Hellcat engines in.
We've been doing a ton lately.
Really?
We even started making our own billet main caps for them. It's pretty cool. So we don't machine too much steel around here, but lots of aluminum.
Yeah.
So we've been
Everything's
machining
shiny,
some
man.
billet caps. What else? Like I said, what's up? Oh, we got the manifolds. That's right.
Yeah.
Good point. So we got the billet, our race manifold for the Hemi. We've got valve covers, all the normal stuff.
And so with this intake right here, would it fit a Hellcat or a Demon?
So it will not fit the factory hood. So if you're building a race car, that's where you need to be right there.
Some of these guys, they don't care, man.
Yeah.
Cut a hole in the hood.
Yeah, if you want the hood sticking the manifold top sticking out of the hood, that's your guy right there. But it's making really good power. We've got them on a couple cars that customers are really, really happy with it.
Do y'all offer a low profile one like that one?
Not yet. We're working on a different top that's kind of in the plans. I think that's probably the way we're going to go, is just to make a low profile top. We don't need a ton more room, but we're looking at a couple different ideas there.
Nice. But this would fit a truck then.
Oh yeah.
Would this fit a T-Rex?
Yes.
Okay.
Yes. What else? Yeah, so that manifold there is we have it currently for LS7, LT1, LT4.
Okay.
Our canted valve head. We've got it for the CID shaft mount head, they call it. It's an LS7. It's like a race head made by CID based off the LS7. And then we have it for the Hemi.
Damn, that thing's monsters.
Yeah, it's pretty substantial piece of aluminum.
Everything. When I was walking around, like noticing all these parts, I'm like, dude, everything is like freaking huge. Everything is so ported and looks nice. Like you still, my whole face fits in
No
there.
doubt.
Like
I know that thing starts out.
not my head, but damn.
It's like I think it's like 400 and some odd pounds of aluminum before it. Yeah, man, it's pretty serious.
We were talking earlier about the billet blocks, right? Which one weighs more, the billet or a billet block, like 427 billet block, or the factory casting billet block?
The casting is lighter.
Oh,
The casting is lighter based surely on mass, just the amount of material that's there. So the casting, again, back to it has more voids. It's thinner in almost, not in every area, but we're trying to balance weight savings to strength, right? Mm-hmm. So no matter how, it can only be as strong as it is, as that the material is actually there, right? So yeah, it's a little bit heavier than the casting, but far more strength.
Oh, okay.
Yeah.
So the billet block's heavier than that.
Correct.
Wow.
Just because it has more material.
Right. Mm-hmm. So if you were to put the same material as the casting, it would be lighter. Right?
It would like if you had the same amount of material, theoretically it'd be the same weight, right? But the billet block would still be stronger because the material, like the tensile strength of the actual material, is higher, right? So it will be pound for pound, the billet block is stronger. But we're adding a few pounds to give it far more strength.
Right.
Yeah, and then how we're some of the design cues and what we're doing to strengthen up certain areas that we know are going to be stressed a lot.
I want to get into the controversial topic real quick, and for the LTs and the LS, could you say the 427? Obviously, it's bigger than the LS3, right? But you have guys out there, or especially tuners or whatnot. They prefer to have the LS3 than the 427.
An LS3 over, say, like an LS7.
Right.
So we're talking more cylinder head base. So you're talking cubic inch, like 377 to 427.
Right.
Okay.
I'd rather prefer that to build than the 427.
Yeah, I don't know why you would want to do that. So it all is based. Again, it's all airflow. If you have enough air to fill the cylinder, the bigger the cylinder, the better.
Right.
Right. So the bigger the engine, the better. So if you have a smaller cubic inch engine, 377 inches, you may, on a given blower, like say you have the same turbo, right? You have the same turbo on a 377 and a 427. If the turbo is not adequately sized for the 427 and is more appropriately sized for the 377, it's going to fill the 377 for longer, higher up in the RPM range, and will ultimately make more power, turn more RPM, and go faster down the track. I would agree with that 100%. Mm-hmm. If you have an appropriately sized turbo for the 427, the 427 is going to beat the 377 because the 377 is it may be run out of, is it going to turn 12,000 RPM, higher than it's not going to be in its efficiency with that size turbo. So it's all about efficiently filling the cylinder. If you can do that on more inches are going to win.
Right.
And then of course you got to put it to the ground.
Right.
So, I mean, there's all the factors involved in racing, but we're definitely proponents of RPM, turning RPM. I'd rather have a smaller engine that can turn more RPM. A lot of that comes into class racing. Right. So if you have to be, 350 cubic inches, I would rather build a bigger bore, shorter stroke engine that's going to turn more RPM with the given class rules than the opposite way around. So,
can you speak on the importance of what you just said right now? Bigger bore.
Yeah, I mean, anytime that you can, well, again, back to airflow. I mean, anytime that you can increase the cylinder diameter, you can take more advantage of your cylinder head, right? So if you have a given valve size, so like on an LS3, a 2165 valve, or on an LS7 2200 factory diameter, if you can run a larger bore on, say, an LS3, right? You get a 2165, and then you open up the chamber to match on an LS3 to a 4125. Now you've deshrouded the valves, intake and exhaust. The potential to make the cylinder head more efficient is there, right? You can take more advantage of the cylinder head that you have and ultimately make more power. So the larger the bore, the better, up to a point, because now you start getting into strength issues. If you're trying to make, 2,000 horsepower, there's a point in which you would rather sacrifice a little smaller bore, like keep it at 4,125 as opposed to going 4,200, right? But if we're building a naturally aspirated engine, you'd be better served going to, say, like 4,185 over 4,125, open up the chamber on the cylinder head, and take advantage of your induction system that way.
What is your favorite?
It's a good question. Really love the LT. I mean, it's more. We've seen on a given combination, the LT makes more power, right, compared to like an LS3 engine, right? But with some of the architecture, like the canted valves, we're getting a lot into the canted valve heads on the LS stuff. I mean, the power potential there is insane. So I'd have to stay with the LS.
Really?
Yeah. There's for a few different reasons. I mean, the LT just hasn't gotten there as far as the parts availability to make real big power, right? So as things progress, but when does it become just a different engine is
right.
Something that I talk about. It's like you have an aftermarket billet block, billet heads, and it's like, yeah, I mean, it's how much of an LT is it now? and you're not running DI,
yeah,
right? So
yeah,
I don't know, but the canted valve cylinder head for the factory being the LT, that's pretty badass to come from the factory with a cylinder head that has that kind of airflow characteristic. So I guess they both have their strong points.
I could agree. I think LS is my. That's where I built before. Not built, but started off with
right.
LS 402 stroker, which y'all offered too, right?
Mm-hmm.
The 402.
Oh yeah.
So that's I feel like a lot of people are gonna say LS because it's cheaper on the dime to build an LS too.
Exactly.
So You know, 1,000 horsepower in the LS is the same 1,000 horsepower in the LT, but it's going to be cheaper to build the LS.
I agree with that.
So, you know?
Yeah, I mean, it just depends on what you're trying to do, right? I mean, if you have a brand new, you know, you get a C7 Vet, you're not fucking with an LS. You know what I mean?
Yeah,
It's like, I can't see doing that. You know, for a nice street car, right? You know, I would keep it LT. Back to our initial discussion with the DI and port, right? I mean, everybody's adding. You already have the DI, so it's not like you're having I don't know. I like the LT.
Yeah. No, you said
I like them both. You know, I guess. Yeah, they both have their pros and cons.
Right.
Shit, I don't even know anymore because I was about to say because if I swapped a car, I'd probably put an LT in it. Right? Because just the value and it's just newer. The LS has been done a million times. So really, I guess after talking about it, maybe I prefer the LT a little bit more. But if you're looking to make all out sheer power, I think the LS, it definitely offers more. There's more out there for it.
Right.
But the LT's catching up. We're working on it.
You think it would break the internet to put a LS, Gen 3 into a like C7 Z06?
Couple guys are doing that. So, racing's racing, right? I mean, shit, people are putting LSs in place of big block Chevys. So, I seen
the LS in an airplane. That's crazy.
I have seen that too.
With the prop on it.
Yeah.
And you started off, you hit the prop, boom, and it just cranks over.
Yeah. We may or may have not built a couple airplane engines.
Really?
Yeah. Not too much to speak of, but
that's awesome, man. That's awesome. What other engines are gonna build? Boat engines?
We've built over the years. We've built LS engines for pretty much damn near everything. I mean, shit, boats, planes. We call them the airboats. Shit, man, all kinds of off-road vehicles. You know how it is. Everything's swapped LS, right? I mean, we've done it all.
Let's swap the world, baby.
That's right.
Can you talk about like a budget build block for someone who wants to make, let's say, 1,000? Because I feel like the 1,000 is
right now. If we're talking LS, I'd still run a 6-liter iron block. That's going to be your best
built by LME.
That's it, man. LME 408, dude. You can't go wrong with that. So that's I mean, for budget, you can't go wrong with a 6-liter iron block. That's going to be your, I feel the way to go. Not a huge fan of the 5.3 setup. I'd rather go with the 6-liter if you're buying something. I mean, depends on how much of a budget you're on, but if you got a little bit of budget, put a 6-liter in there. Then you're opening yourself up to a ton more cylinder head options. You can go LS3. I think an LS3 head on a 6-liter is probably your best. If you're looking to build something nice on a budget.
Can you give us like a more in-depth answer, like what crank you'll use, what rods, pistons?
Man. I'd probably, if you're doing that, I mean, I'd probably find like an LSA crank. Do an LSA crank in a 6-liter iron block. Rods, I mean, find some cheap H-beam rods from wherever. Mm-hmm. If we're really going budget, and then just a quality piston, diamond Y-scope piston, and machine it for 1/2-inch studs. Again, how budget are we talking here?
Yeah. Oh, right? Well, not.
But to go for a combination like that. I mean, the LSA is a nice forged steel crank that can be had. As long as you get creative, you can find stuff for real cheap like that. Mm-hmm. Somebody's got a blown up LSA that the crank's block's bad, and the guy don't care about the crank, a couple $100 for the crank.
I don't think good. Is there many LSA cranks out there like that? I don't think there would be. There is? Just floating on shelves?
Oh yeah. No, I mean, so we're talking, it's a nice, easy way to get a forged crankshaft, right? As opposed to the nodular iron standard crank. But that's the route I'd go.
What about heads?
As for budget, I mean, an LS3 is probably going to be your best performing cylinder head, like bones, out of the box, not ported. I think that's what I would do.
And they can make 1,000 with it. On boost.
On 100%.
Okay,
yeah, easily.
Well, it's because you didn't mention that.
Yeah, not naturally aspirated. No,
Yeah.
But yeah, it boosted 6 liter with LS3 heads, 1,000 horsepower, no problem.
What would that run as far as cost wise?
I don't know, man.
Because we're gonna have Joe Schmo on Facebook looking at this, and they're gonna be like, "Man, that's gonna cost. If it's LME, it might cost arm and a leg or something,
Right.
So what would it cost from LME?
Cost you your left leg. I don't know. Shit, I don't know. I'd say at least $5-6 grand. I mean, if you the whole budget part of it is where you got to start thinking about where are you getting these parts from, right? If you're calling us up and we're sourcing new parts, we're not running around eBay trying to find you a $200 crank,
Right.
But if one were to come up and say, hey, I've got a block and a crank and a this and a that, we can definitely machine a block, assemble it the proper way with budget components, make a bunch of power and be good. But really our target market are guys that are looking to make power the right way and not necessarily say they built it the cheapest, because that's really not my goal, is to say, hey, I built you the cheapest engine I could.
Right.
And we've been doing this a long time. We're professional engine builders, and that's just, we're looking to build the best engine we can. Now, not to say that you can't take quality parts or a budget part, let's say, or that was had in a budget way, and make it a dime piece of an engine. So,
well, I think my question got a little jacked up, but from LME, what would be your block you would sell somebody to make 1,000?
Right, I would still go back with the 6 liter. So they discontinued them a while back. Like, if we really have somebody that we're trying to get going, we've procured a used 6 liter iron block, goes through our whole process just like normal, and that's honestly, I mean, if you have to start out and you're trying to make something the most out of something, that's the way I would go, is get you again the 6 liter iron block and then build that up. So you can't build something with an aftermarket block, I mean, and be in any kind of budget. I mean, you see the prices of these things are going up and up. I mean, it's crazy. So like, when the LSX block first came out, I think it was $1,800. They're what, $4,800 now.
Damn.
Something like that. I mean, that's pretty accurate numbers. They're getting up there.
That's crazy.
Maybe $4 grand, but they're double in price from when they started, and that's just regular inflation,
Right.
But you can still go down and get you a 6 liter for a decent price.
Did you notice a shift or a change as far as like business when COVID happened?
I think there's been a huge injection of enthusiasm into the racing and performance market. 100%. Like, guys, I think people found their passion, or it kind of was
evolved,
refueled in a sense, when they were stuck at home, not being able to go out and do their normal thing, right? And hey, they got their hot rod in their garage that's just chilling, that they've never worked on in 5 years, 10 years, because they're busy doing with other things, right? So now life slowed down. You can call up. We didn't skip a beat, man. We've been machining the whole time. So things went quiet for a little bit, and then after a couple of weeks, it was like, hey, I'm thinking about putting heads cam on my vet. I'm thinking about building this, that, and a lot of definitely a lot of people struggled in that time, no doubt. But there's a lot of guys that didn't lose their job, but now they're just stuck home. So they're making the same money, and they got nothing to spend it on, and they like to go fast too. So I feel like the enthusiasm in the market got a shot in the arm for sure, and I don't think it slowed down one bit, honestly, since COVID. People are gung ho about making power and going fast.
Yeah. What is the most highest powered block you have right now?
Highest powered.
I didn't read it. I didn't read your
So,
manuals.
you know, like what we offer, I mean, in for racing, I mean, just all out racing, we got some stuff going together right now that's making over 4,000 horsepower.
Fuck.
Yeah. So that's a LS base cannon valve heads, half mile racing.
Damn.
Shout out to Morris Malone. We're going to go try to set some more records with that thing. I mean, since you brought it up, man, that thing is going to be nasty. So it's going together right now. We're looking to see what the block and what the power plant is really capable of.
Wow.
Yeah, man, it's going to be pretty good.
4,000 horsepower.
Yeah, legit 4,000 on an LS. And he was already doing it, but we're trying to surpass that and like go the next little bit.
Can you tell us how that one's built and like what motor is it? You know.
Yeah, so I mean it's a billet block. It's our cannon valve heads. It has a Winberg 4100 stroke crank. It's got 4140 bore pistons in it now. You know, big nasty turbo cam. All the best of the best stuff. I mean, 937 Jessel lifters, belt drive, some big nasty push rods, Jessel rockers. So really nice valve train. We're turning it over 9,000 RPM and making 4,000 horsepower.
And that's what cubic inch is that?
It's like 441 inches.
Damn. And that's still like considered LS based block. Mm-hmm. Damn.
Yeah. So it's aftermarket billet block. I mean, there's nothing like we were back talking earlier. I mean, it's based off an LS engine. You know, it has a LS, you know, bell housing pattern. The architecture is LS.
Still push rod.
400 bore spacing, push rod. It's an LS block. Yeah. But it's a solid, you know, no water in it.
Okay.
It's run on methanol. You know, I think he's pushing like over 60 pounds of boost or something like that. It's pretty serious setup.
It's a gnarly setup, honestly. And have y'all pushed like factory stock LS LT blocks here to see the limits and to actually?
Yeah, we usually break them around 1,500.
Really?
Yeah. They definitely will have some issues. A production LT block will have issues at like 1,500 rear wheel. You're going to start seeing every once in a while some block failures for sure.
Where does it normally happen?
Right in the main saddle, like right in the main web of the how do you call it? The main bearing where it starts going up to the cylinder.
Okay.
Up to the cylinder, yeah.
And is it like a GM issue or is it like more like
no? It's no issue. I mean,
material?
it's just, the block was designed to make 400, you know, whatever factory horsepower, and now you're tripling the horsepower.
Right.
So it's just a matter of that it cannot withstand that cylinder pressure, those pressures. I will tell you that back to our discussion earlier, sometimes when you're sleeving a block, you're taking strength out of the cylinder case. You're gaining strength in the cylinder wall, let's say. You know, you've got this badass sleeve. It's great. You could put it in a top fueler and run it, right? But what did you just do to the architecture at the bottom of the block? For example, in an LT where the main meets the cylinder wall there, where it all ties in, bulkhead of the block, you're taking a shitload of material away from that area, and you overstress the block, and that's where you're going to see a crack.
Right, because the stress has to go somewhere else, right?
Yeah, I mean you're making all that power. I mean, that just incredible amount of force is going on.
Damn.
So and that's where the billet blocks really are the answer, because you have either more material in the areas in which you need it. They're purpose built to work with that larger OD liner, and then the tensile strength is just so much higher than the production cast aluminum.
So 1,500 is like what your max.
Yeah, I mean, so exactly. So we have our 1,400 horsepower LT short block, long blocks. That's based off of the production block, and that's where we feel like, hey, we're
safe.
We're good with that.
Right.
If you're looking to go more, you go into like the LTR. LTR is the concept aftermarket block, 6-bolt per cylinder. It's got the priority main oiling, billet caps, all that good stuff. Or you're going into like an L8T, the iron block. And then the next step there is the billet.
Billet.
Yeah.
The LTR, is that your newest? Production.
Yep. So it's an aftermarket
your
block.
latest
They're cast in machine in Indianapolis, and it's killer block. Really nice block. It's got a lot of. It's essentially, if you think about it, it's an aluminum version of an LSX block, but it's LT. They have both LSR and LTR.
Okay.
So if you picture the LSX, GM block, 6-bolt per cylinder, priority main oiling, it's got all those features that into an aluminum block. So you can take advantage of the 6-bolt heads. So there's a couple out there. There's our LT race head that we offer, and based off of the Edelbrock casting, and then there's the CID head that has the 6-bolt provisions for the LT.
One question I've always wanted to ask an engine builder, whenever they're I don't know how to really say this, but whenever they're showing heads or blocks, right, around the port of the exhaust valve, there's like these purple or green markings they usually have around the, right? It's like
Where are you talking now?
on the exhaust side of the head,
Right.
and they're like purple or green, whatever color there is, but it's just like a stamp like around it. You know what I'm talking about?
No.
I'm not sure if it's like a blueprint or like it's printed on there.
I think
Or they sometimes they're on the valve side.
right there where he's pointing.
Yeah, they usually have them right there too.
Oh, that's just going to be your seal. It's like instead of running an exhaust gasket, you will have an O-ring seal there.
No, it's not that. It's not a seal.
That can be on the intake or exhaust.
It's usually like purple. Like it's like a color they put. I'm not sure if it's for porting.
Oh, it's called Dicom. Well, that's a brand name. It's just a metal die.
Oh, okay.
And that's for laying out the port. Like if you're going to port a cylinder head by hand, you're not talking about on a running engine, just like when they're building.
Yeah, when they're building. Yeah.
So
what's it called again?
the brand name that most people use is called Dicom. It's kind of like a Band-Aid. They just call Dicom as like it's a brand name, but that's what they call it. But it's metal die. And you just put that layout die is what it's called. You put that on there and it scribes really easily. So you have a sharp scribe, and then you'll put the gasket, let's say, or your template for your intake port, the dimensions, you can lay that out, you scribe your lines, and that's what you're going to port to. So like if you're figuring up cross-sectional areas or mapping out your port, that's what we used to do when we were porting the heads by hand, is we do that on the intake, exhaust, and on the deck, lay out all your lines, and then you're porting to those lines. And that gives you a basic layout of the dimensions you're going for. Then you'll use snap gauges and, calipers and such to achieve the cross-sectional areas at certain points in the port. Okay. But that's what that is.
Yeah, nice. I always wanted to know that.
It just scribes real nice. You can make a sharp line and then actually measure with a caliper to those lines. It just gives you a nice, clear representation of what you're trying to do.
And you can get those. They have those like in green and purple and stuff.
Yeah, I mean, yep.
It don't matter what color it is, just color. But
blue and purple is probably the most common.
Yeah, I see like when they're selling heads and they see them and you see them around like the exhaust and stuff like that. The intake. I
always like to clean it off after you're done. Some guys leave it on there and it looks a little tacky to send the product out with the freaking dieback still on it. You want to take some lacquer and just clean that shit off.
Thinking about the LT, right? You said that y'all pushed them pretty much to 15 and then they break, right? Why is it that
some do?
Some, okay. Why is it that you've seen the Coyote hold more power than the LT?
It's all about it's a stronger architecture as far as the parent aluminum that's left in the block after the sleeving process. It's bottom line. There's just more material behind the sleeve. And whenever you have more material behind the sleeve, the cylinder stays rounder and straighter longer. You're going to have better, longer quality ring seal, right? So that, and then you have more material like where the cylinder starts meeting the bulkhead of the block, the main saddles and all of that. So if you have more material behind the sleeve, there's inherently going to be more left at the bottom as well. So it's just all about having the right amount of material in the right places. And the Coyote just has more in the areas needed from the factory than the LS. So it makes it a better candidate for sleeving the production block.
Got you.
Yep,
Man.
that's the answer.
That's my answer, babe. You know what block I'm going with now, right? Nah, I'm playing. Nah, I do want to start a build. I do want to build something soon. You know, Coyote. Obviously, that's the newest and greatest. But I might go back with LS. I'm not sure. It's cheaper. You know. So I don't know. What do you think? Should I go with Coyote or LS?
As long as LME.
Right? Oh, damn. I don't know, man. I don't know if I have LME money, you know? I have to get that money up.
That's why you got this podcast, man. Come on.
Let's get into maybe your intakes.
The looks speak for themselves. I mean, we pretty much got them for all the different applications. If there's something that's just a must-have, you know, and there's a demand for it, we can make something new. I mean, that's one of our strong points here is that we can actually just make new stuff based off of, you know, requests, market demands. We get in on a computer, draw it up, and make something out of nothing. So we're not relying on some other company, some designer somewhere trying, you know, telling them, hey, we need it to look like this, that, or the other thing.
No third party.
We're designing it and machining it, and then we're testing it in house. And that's really one of the things that gives us that edge is that other manifold manufacturers, they're relying on third party testing. It comes off the machine. It's right on the dyno, back to the testing, back on the dyno. It's a really a nice setup. We can just evolve our product pretty quickly.
Can you talk about your as far as your quality control and your testing? You know, when a block goes out, or not pretty much goes out, but like what's your procedure on testing that block?
So, on testing a built long block
Or short.
Well, the short block, you have to rely on your machining quality, all of those checks, right? I mean, we're checking, of course, all 5 main bearing clearances, all 8 rod bearing clearances, the whole 9 yards, you know, surface finishes on our rod journals, on our cylinder wall surface finish, the deck surface finish. You know, that comes down to expertise and, you know, attention to detail and making sure that everything is clean, machined properly. The cleanliness is huge. That's one thing that we really pride ourselves on is the cleanliness of our builds. You can do the best machine work in the world. If you don't clean the block properly, you don't clean the components properly, it's all for nothing.
Yeah.
But as far as like real world testing, you know, we're running a long block. All long blocks get dyno tested. So we have a pretty stringent break-in procedure that we follow. You know, we're leaking down each engine, checking compression. We have a blow-by meter on the dyno, which actually allows us to measure in CFM of blow-by getting past the ring. So every engine has some level of blow-by. It's just how much is the key, right? So, you know, we have a parameters of, hey, you know, we know it needs to be below this threshold.
Like a tolerance.
A tolerance, exactly. We run 1002s on the dyno, 1 in each primary tube and 1 in each collector. So that allows us to monitor and adjust air-fuel ratio per cylinder. You know, there's a lot, and that goes back to manifold development. We can see the distribution in our manifolds. We can make adjustments in that regard. Gives us a lot of feedback when we're dynoing something to see how it's going to last. You know, of course, we're checking the oil that's coming out of the engine, cutting up the filters. So there's a whole checklist that's gone through on every single engine before we ship a long block. You know, we're doing our damnedest to make sure that it's right where it needs to be.
So if it blows up on you first.
Yeah.
And then you'll fix it, right?
Of course, man.
Right.
Yeah.
We're
pretty fortunate to have very little issues in that regard.
Nice. I know when it comes to high performance aftermarket parts, they're usually a lot of companies don't offer warranty, right? Do you offer like some type of warranty or anything?
We have a 90-day warranty on our stuff, but more so it's the company that stands behind it. I mean, there's tons of warranties out there in different, you know, in this market, in the high performance engine world. You know, they might offer some kind of crazy warranty, but then it's never under warranty, right? We work we work with a customer. If there's an issue, if there's ever an issue with one of our engines, the customer can know that he can come to their sales guy. We'll explore the issue. We want to do and find what the issue truly is, not just the end result, but the root cause. And we'll get down to the bottom, the best figure it out, and make the appropriate call. You know, I mean, there's so many things so many variables out there that can happen when you're making 1,200 horsepower and racing and everything. So, you know, I like to say like, hey, you know, let's say a customer burns a hole in a piston because it, you know, bad fuel or whatever happened, right? Look, you're our customer, bring it back, and we'll do our best to get you back up and running at a least cost possible. You know, it's like kind of we're all racers. We're trying to work together to get the job done.
Because I know, especially, I feel like this is a breaking point with a lot of these guys that have programs, right? Whether they're in bracket racing, whether they're in street racing, grudge racing, like that's the big key point is, you know, the product and the warranties, right?
Right.
Because you can go to Texas 2K and you have, let's say you have I'm not gonna name any tuners or anything, but you have a tuner that justifies everything that's going on with the car. Then you have the engine builder that's, let's say LME, right? Then you have the assembler, all the ones that put everything together. There's so many variables that can go wrong,
right?
Whether it's engine management, whether it's the tuner, you know, tuning the engine management, the block itself, fuel, so many variables. But like when it comes down to the nitty gritty, I feel like people just want a product that they can stand behind. For sure. Know, like if something goes wrong, they want to go to LME. Like, hey man, this messed up. Can you talk to maybe my tuner? Or how? What I'm asking is like how far in depth do y'all go with that? Because, you know, there's a bunch of like, oh, he said, she said when it comes to that, right? Like, well, my tuner said this, and my assembler said this, and then it just becomes like this whole cluster,
right?
You know.
So when you're talking, we are talking about engine, like an engine issue, an engine failure, an engine, you know, something coming apart. Typically, and sometimes it's very difficult, is the engine will tell a tale, right? And, you know, at the end of the day, you can either have, you can have an assembly issue, a machining issue, but you can have a parts issue as well, right? Or, you know, then you can have a tuning issue or a fuel delivery, right? The tuner can put all the right numbers in, but if that actual amount of fuel doesn't make it into the cylinder, you know,
right.
You know, hey, I commanded this air fuel ratio, but that's not what actually happened, right? So, you know, a melted piston is a melted piston. You know, what else is there to say, right? But a broken part, at some levels, you know, shit breaks. You know what I mean? If you're making, you know, 1,500 horsepower and turning 8,000 RPM, hey, your parts can break. You know, the best racing teams in the world with unlimited budgets, you see them on TV. You know, cloud of smoke coming out of the back of the tailpipe, and what happened? You know what I mean? Did they not spend enough money? Oh, I think they spent enough money. they you know, just shit breaks every once in a while. But the engine usually tells a tale, and you know, I think that's what makes a quality company is, hey, if something, I will tell you, in our experience, and there's not many instances where we're just like, you know, we got a bunch of guys working here and we're all human, right? If somebody forgot to do something, you know, there is that, right? You just got to own up to that, stand behind it, fix it, and move on, right? Mm-hmm. You have other instances where you have parts failures, and that's kind of one of the fucked up things in this industry is you can make pistons all day long. If the piston fails, the let's say a piston, right? Or whatever part, the part manufacturer goes, hey, I'll send you another set, or I'll give you a really good deal on another set, whatever it may be. Well, that's great, but that's $1,000 compared to like $30,000 fix we have here. You know what I mean? That's on the engine plus the other 10, 20 it's going to take to put it back in the car, right? So whenever you're building something of this magnitude, you're going out racing, people throw around horsepower numbers like it's candy these days.
Yeah.
Oh, 1,200, 1,500, 1,800. Well, that's a lot of horsepower. There's a lot of stresses on things. Things are not going to last like you might think they will at, when guys were making 450 horsepower, right? So you have to go into the game knowing that you're taking a risk every time that you go out to run your car. If something does happen, then you want to be partnered with the right people so you can get back on the track with the least amount of downtime and expense, right? And I think that's where we excel, because there's a lot of big shops that work with us because we stand behind our stuff. Mm-hmm. You're always going to see you're always going to have an issue, no matter what the root cause is. It's how you handle it, and I think we do a really good job of that.
Nice. I think you answered that question great, honestly. Cool. Because I see that an issue when not only doing podcasts but shops and stuff, and they do the finger thing, the pointing finger, and especially the customers watching out there, and they see that, and they know, like, okay, well, this 3-letter name engine builder, don't go to that guy, Mm-hmm. So I feel like that's a good you made it a great point on that. You can just stand behind your work. Obviously parts fail, right? And especially y'all are doing engines. I'm in aviation. I see it every day. A part costs $125,000 sometimes, so these parts are going to break. That's just how it is,
Right.
They're just machines at the end of the day.
They're just machines. At some point, it fatigues. You can only move a connecting rod, up and down so many times. It's gonna fatigue at some point. So yeah.
If I have an iron block, right? The reason why I wouldn't go with the billet block is because price, mm-hmm. right? Can you tell me the pros of going with a billet block versus keeping it the factory iron on an LS or LT?
So at sheer power, we've definitely seen the billet blocks be able to handle more power. So the baddest iron block you can build, right? It can only go so far, and then you have to step up to a billet block if you're going to really make the power. You've got the ability to repair the block. You can weld and do more repairs. You can have a catastrophic failure inside a billet aluminum block, and repair it. So you're not, you might have $8,000 in an iron block that's all machined, ready to go. $4,000 block with $4,000 machine work, let's say, doing all the different things to it to make it a race engine. Then you have a $14,000 billet block that gets grenaded, and now you can actually fix it for whatever it costs, say $1,000 in welding or whatever, and now you have a block that's not. You see, there's some flexibility there as far as repairs, when you're really going racing, and a billet block, you have more flexibility from the manufacturer to put in features that you might need, right? So a casting is very well set, right? Well, once you have your tooling and everything is made for a casting, you're sure as shit hoping that you have the right features in your block, because you're not going to go back and you don't want to go back and change that tooling. Mm-hmm. A billet block, for our stuff here, hey, we're down the road and everybody needs this fitting in this spot because that's where the new supercharger, whatever is, you know what I mean?
Got you.
We can go, okay, it'll take some programming, take some time and effort, but we can, relatively easily go in there and add that boss right there, or add that fitting or whatever we need. So there's flexibility in design, mm-hmm. and the flexibility of design is a great pro. And I guess you got weight, right? So weight, strength, flexibility of design, and the ability to repair. That's billet block.
You said weight. What you said earlier?
The weight compared to an iron block.
Oh, okay.
So a cast. I don't know if I hope you were talking about a cast aluminum block compared to a cast iron block prior when we were talking about it. But a billet iron block, billet aluminum block is going to be lighter than a cast iron block.
Okay.
Right, but not lighter than a cast aluminum
Got you.
production block.
Got you. Got you.
Right. Yeah, I mean, you put a dart iron block LS next to a billet block, and things are fucking heavy.
Yeah. And so on the LS3s, like an LS3 aluminum, could you stress those as much as an iron?
Not even close.
Why is that?
For all the LS3 block in particular is the weakest block GM has produced yet that I know, compared to an LS1, LS2, LS7. One might argue because of the sleeve, there's some inherent sleeve cracking issues, but as far as the LS3 just inherently is not a very strong block for boosted applications. 800 horsepower, I like it around there, but to just go and if you're building 1,000 horsepower, 1,200 horsepower in an LS3 and you're really trying to like beat on it, race it, let's say it's an off-road buggy or something like that, you're really going to stress that block. An LS3 is not a good choice. The LS2 aluminum block is stronger than an LS3.
Really?
But they did a really good job with the LT. The LT is actually really strong. I mean, we're talking 1,500 horsepower, but that's pretty damn good out of a production block, in my opinion. So, yeah, I mean, just that's some knowledge that you can take with you, is that the LS3 block, and I've been preaching that for I don't know how many years over the phone with customers, like, day in and day out. It's like they're trying to set the world on fire with the production LS3 block, and it's just not the way to go. You're better off. I mean, we've changed guys over from an LS3 block to a 6-liter iron block, or you change them from an LS3 even to an LS2, right? When I'm talking before there was all these other options.
Right.
But yeah, the LS3 block is not very strong. LSA and LS9, they're better, right? But
the LS9, the aluminum?
So the LSA and LS9 are stronger than the LS3 because of the material. There's some design things.
What is the difference?
It's the way that the block is cast, and it's the actual material that's used. Excuse me, I think that's in the cylinder head, is the way in the method in which it's cast. But the LSA and LS9 have better aluminum, higher tensile strength material, and then they have better main caps. Like the LS9 has a steel cap, and then the LSA has a nodular iron cap.
And so for those that are watching that don't know where these engines are coming from, the LS9s came from the ZR1,
Correct,
and the LS2 from the TBSS Trailblazer SS.
Yeah, LS2 is using a bunch of, like, the Corvette had an LS2.
07, and then the LS3 is like 09 Corvette. Right. Okay. And then the iron is like a truck, right?
Yep. Exactly.
LQ4, LQ9. Right.
Mm-hmm.
Okay. So they're probably like thinking, like, damn, where did you get all these blocks from?
Before this podcast, you need to spruce up on your LS engines, what cars are actually in. But we're talking just straight engines. So LS3, not the best choice.
Damn, that's crazy.
Yeah, and that's probably the most prevalent block that's out there. There's a ton of them out there, but they're great. They're great engine. They're great engines. I mean, naturally aspirated, a little shot of nitrous, moderate boost, they're killer. But if you're really looking to stress something, there's a difference between guys that are just going out, they got their little hot rod and they like get on it every once in a while, and it's not really a thing, right? But if you're really like hardcore racing, going out to the track all the time, or just really putting it through its paces a lot, that's where you start to see the deformation of the cylinders, and you start to really see the degradation of your ring seal over a short amount of time, as compared to a guy who goes, oh, I've had my 800 horsepower LS3, for 10 years and it's been fine. Well, he doesn't do anything with it.
Yeah. Yeah, that's true. Yeah.
You can do a lot with a little, as long as the engine is built properly. It's all about the crankshaft geometry, the cylinder wall geometry. Having all of these tolerances set up for this particular application, a clean assembly, you can do a lot with parts that you might not think. I mean, there's a lot goes into the way the engine is built. Like if you gave me a stack of parts, you gave late model engines a stack of parts, and you gave the same stack of parts to some other guy.
Joe Schmo. Yeah.
You can build a substantially nicer engine with the exact same components by paying attention to all the details and the machine work and assembly of those components. That's the difference between a professionally built engine
Right.
and somebody that just pops something together.
Yeah. So you don't. So let's say this is going to be for the Facebook guys, right?
Okay.
Let's say they get an iron block and they want to make 1,000, right? Could they leave the factory crank on there? Let's say throw some pistons and rods in it. Just like get the pistons, pop the caps out, put the pistons in, put the ARP bolts in it, pop it in, put the piston on, bolt it together.
There you go.
Would it run efficiently?
Well, technically no, because you have to balance the crankshaft, right? So you
Okay.
got to pull the crank out, you got to balance it.
Okay.
But no, so here's something to think about. The tolerance, like bearing clearances, for example, right?
Yeah.
That's a huge contributing factor to how much an engine can make before it has an issue with a given component, right? So having the proper bearing clearances. So for example, like an LT4, right? There's LT4s that last. This is my opinion now. There's LT4s that last, that you can beat the shit out of all day long and they never have an issue, right? And then the next guy puts a cam in his car, goes beats on it, and he spins a main bearing, like, almost immediately, right? Well, what the hell? The factory tolerance in that engine block is a decently a wide spread, right? It's something like 0.8 to 2.5 thousandths or something like that, right? So that fluctuation or that gap in tolerance, if you have something that's built at 2.5 thousandths main bearing clearance, and then something that's built at less than 1,000ths bearing clearance, the tendency for that engine that's built tighter to have an issue at a higher horsepower range that's exceeding the factory limitations, what it was originally built for, that's going to be the engine that fails, in my opinion, right? So having an engine builder optimize the tolerances, specifically the bearing clearances for your application, and that coupled with all the other things, surface finish and those are going to be the ways that you can make an engine last and like, man, it's like, hey, I can just beat the shit out of this engine day after day, and just lasts. And we have customers that call us up, like, hey, I got 50,000 miles on this thing, making 1,200 rear wheel, just beat the shit out of it all the time. And it's like, that's the difference between, I'll tell you, I see guys around on the internet and they try to it's like a contest to see how tight the bearing clearance they can get, and it's like, there's an award for that. I don't know, but, building an engine with 1.5 thousandths main bearing clearance on a 1,400 horsepower engine is, that's boggles my mind.
Yeah.
Sometimes.
Damn. So I keep looking at this intake. When did y'all develop this intake? Because it looks very similar to others.
That's like the OG, man.
Yeah, that's
what all other intakes are based off of.
Oh,
yeah, so I don't know how long we've had that, but it's been quite a while, and I would venture to say you'd have to do some internet research here, but I think that manifold has been out longer almost than anything else out there that you can think of.
Looks very similar, man, honestly.
Yeah.
But it looks badass.
A lot of people like to emulate greatness.
Do y'all get that a lot?
What's that?
Like
compliments on our stuff?
Well, not compliments, but other people, not so much per se copying, but grab the ideas.
We do get that a lot. In particular, in some cases, there's only so many ways you can make a part, right? Sometimes the part just needs to look like the part. But, as far as manifolds, there's been quite a handful, even just recently, a couple places copying our stuff almost to the T. So,
really?
You kind of take that as a compliment, right?
Yeah.
And then you just move on. What are you going to do if somebody wants to copy your stuff? It's like, hey, now it just gives us more, fuel to create something
better,
right, newer. So
that's awesome, man.
Yeah, man.
I think y'all had it in 2015. I want to say
2015. I'd have to look, dude.
Yeah.
I really wish I knew that stat because,
Think I seen it, and then do you know?
I don't know.
you know,
Yeah.
dang.
I just know the imitation is the sincerest form of flattering.
Yeah, that's a good question. Is when we first made that manifold? Huh.
Like the design of it,
Yeah.
you know? It's awesome.
We created that our original low profile manifold, the whole driver for that, and that was really our first billet product. Was that manifold? It was we were building tons of LS7, you know, high horsepower LS7 engines, iron blocks, aluminum blocks, whatever, and they're all going in Z06s, so or C6 Corvettes,
right.
and customers were on the phone and they, hey, what manifold should we run? And there literally there wasn't anything else out there. It was like there was like a fast manifold, right? And those were ballooning and breaking and having issues. So it was really like, hey, I was literally had to start telling people to put a production LS7 manifold on this killer engine that's, that far exceeds its capabilities, but out of sheer strength, right? Because you can only, if you can't boost the engine because it's going to break. Yeah. So the LS7 manifold was an option, right? There just wasn't much out there.
Or they had the Holly that would stick out. Yeah.
That was even out.
Oh, damn.
Okay. I think that was before the high ram for sure.
Yeah.
Maybe I'm not a high ram historian, but so we set out to build a manifold that would fit under the C6 hood. Yeah. So that manifold just in turn fits under an F-body hood. It fits under a C5, C6, C7 hood, and just works really well. And the factory hood closes, life is good. You can make a lot of horsepower, high RPM, and that was a development story on that. Yeah. Is literally there was nothing else out there. So if there was any other billet manifolds at the time, I wasn't aware of them. Yeah. And that's crazy. There was some sheet metal stuff we were messing with sheet metal. We had a couple guys that were making some sheet metal manifolds for us, and they are what they are. But everybody loves a billet aluminum manifold. So that was kind of I think it was the first, man.
Yeah. I need to make some Ford Coyote ones.
Right?
That would be cool. We can
definitely.
I mean, it's the same freaking intake. Just change the ports, right?
It is. I think we're gonna do something similar to that. It's probably gonna be our first Coyote. It's gonna be more geared towards that direction. But we can definitely do something in the future with a low pro.
You know what I haven't seen? I haven't seen an F-150 truck style Coyote intake.
Because when you say truck style,
like high ram.
High ram.
Yeah, they're more like low profile, like this on it.
This may get the job done for that. Because this is a big manifold. Yeah, so you're gonna need something. Tall deck. You're gonna need something to fit it under, but it's coming down the pipe, man. Yeah, we've gotten that in the works as well.
Nice.
Yeah, man. If we're gonna do it, we're gonna do it right.
Yeah. Well, it seems like this podcast, I don't know, man. Hopefully, something comes great out of this podcast, and we can see more. I'm sure I have a lot of Ford. I have a lot of Ford Coyote enthusiasts, subscribers, followers, and I pretty much interviewed a lot of guys from the Ford Coyote.
Well, once we get our program like truly up and running and ready to, I'd like to. You can come back and kind of give a little behind the scenes of what we've got going on and a couple different products, and just let the engine speak for itself.
Yeah, for sure. Is there a certain temperature y'all build engines at?
72.
72 degrees, right?
Yeah.
Why is that?
No. It's good to be consistent. Yeah, I mean, ambient temperature, you want to be in that like 72, 74. Yeah. Something right in there. But yeah, definitely like when we're measuring components and things like that, you want to stabilize everything to be the same. You get some expansion and contraction of materials at different temperatures. But yeah, in the assembly room, we like to keep it.
Yeah. So you're not building them like out in the shop and stuff like that.
What's up?
And you're not building them in the warehouse, right? Like
no, we have the machine shop area, which is AC'd and heated. So all that's AC'd. And then we have our closed assembly room. So once everything's been machined, cleaned, brought into the assembly room, and then we'll do all the final fitting and assembly in there.
Nice.
Yep. Yeah, we got 7 stations that we can assemble engines, so we can have theoretically 7 engines going together at one time. So pretty efficient.
Do y'all running like an assembly line?
No, we don't. So one guy is going to assemble the entire engine. The machining process goes through a couple of guys, through our process, different parts of the shop. So essentially, we run an engine machining operation, a cylinder head machining operation, and then we have our CNC, we call it, is all of our billet components, and then that's also partially comprised of the CNC cylinder head department, right? So all that flows through, and our cylinder head guys work closely with the engine assembler to make sure that the cylinder heads are set up properly for that combination, and then one guy takes it from all the way from the cleaning of the block to the finished long block. Keeps less, you know what I mean? Keeps less hands.
Oh,
and
gotcha.
you're focused on building one engine, not just handing it off to different guys. One guy just doesn't put in pistons, one guy.
Oh yeah. I got you. Yeah, we're definitely gonna take a tour after this, and then we'll check out everything.
Sure.
See how everything's done. Yeah. I think 2014, 2013, I was running what are they called? PRC heads.
Okay.
From Texas Speed. What manufacturer do y'all run? Do y'all get heads from?
So we run a few. We run Edelbrock castings. We run CID, Brodix. Those are our primary castings. All of those are cast and machined in the U.S. I think that's something to be said about that for sure. I mean, utilizing American castings is the quality's there. Some of the castings are hip that we're using, which is a whole nother process, gives you more density in the aluminum. A lot of our race heads are done in that manner.
They're what again?
Hipped. So it's a process in which the cylinder head is heated in a chamber, and then it's compressed with helium, I believe it is, as part of the hip process, right? And it essentially crushes any air bubbles compresses air bubbles that are internally in the aluminum. So air is compressible, so that little air bubble gets pinched down to nothing, and it gives you density similar to a billet head, but in a casting. So some of the aluminum blocks are hipped, and your higher end cylinder head castings are hipped as well. But those 3 manufacturers pretty much cover the gamut of all of our LS LT aftermarket heads, and then we have some of them we machine from the raw casting to the finished product. We'll get it straight from the foundry, which is great because it gives you a lot of flexibility in design and those types of things. And then we have our own programs. We've done all of our port development for all of the different platforms in each one of those castings. So it's a lot of work.
I noticed most of your blocks are assembled, if not all of them, with copper gaskets.
The ones you see in here are. So all of our race engines use copper gaskets, our highest horsepower engines. So at some point you exceed the limits of what a MLS gasket can hold, right? So that's our like a top fuel hoop setup. We always use a copper gasket in that application.
Why is that on the copper? Why do I use the copper gasket?
So the copper is really it's driven by the design of the hoop, right? So it's a malleable metal. It's a very soft metal, right? It's an annealed copper, nonetheless. So it's very malleable, and you have a receiver groove in the block, and you have a hoop in the head. So the hoop protrudes out, say 20 thousandths, let's say 18 20 thousandths, and then you have a receiver groove to accept that hoop. Well, now it's like a male-female fit, positive mechanical lock. And the copper is just a medium between to get sandwiched in between those two. And that's the best, most effective way of sealing cylinder pressure. So your top fuel dragsters use something similar.
I think you answered this question before, but if you can answer it again, or maybe I didn't ask it, but what is your top or your most selling block you're selling right now?
Right now, for sure, is the LT, specifically an LT 416. right?
Okay.
That's the cubic inch that's most popular. We're doing a ton of 427s. We do a ton of 390s, even some 400 cubic inchers. But the 416 is really the most popular. It's the most cost-effective way to get the cubic inches, right? Because you're not sleeving the block. It's a 4070 bore with a 4-inch stroke. Man, we just had a ton of success with it. They last great. They make killer power.
What do they hold to?
That combination is our 1400 package.
Okay. And what does that run as far as price wise?
I think they're right at 12 grand, something like that.
Okay.
Yeah.
So they're not
Between-
an arm and a leg. Then.
No, I mean it's right where it needs to be for to make it affordable, good power. I mean, it's really nice components, all the great machine work. I mean, it's just like the machine work that is done on our, I don't even care. It's the most budget thing we offer, right? So it's our whatever.
Yeah.
Say it's a 1400 horsepower LT or a $60,000-$70,000 competition race engine. The same core machine work is done between the two, exact same. There's no, you're spending $5,000 on whatever. It gets the same machine work as the best of the best. The price difference is in all the components and the additional machine work to make all of that work. But your basic line hone, deck, bore, hone, cleaning of the block, the assembly of the short block, that is unchanged from a $10,000 short block to a $80,000 complete engine, whatever it is.
Yeah.
All the same.
Have y'all worked on the LT5?
Yeah, we've done some LT5s. Yeah. Yeah, you're talking the ZR1 engine.
Yeah. The new C8 engine.
C8 LT.
LT2. I'm sorry.
That's C8 engines LT2. Yeah. So we've been doing quite a bit. The LT2 we got the billet block.
That's right.
That's what that is. That's what I'm saying. We're ahead of our time, my friend.
Oh shit.
That's a fucking LT2 C8
Damn.
Corvette billet block. That's where we're at. So this one too, both of them. So you can tell by the secondary oil scavenge pump that goes right here.
LT2.
They're both LT2.
Damn.
Yes, sir, with water. So this is something that's capable of making 3,000 plus horsepower in a C8 Corvette. All you got to do is find a way to tune it.
And I was about to say.
You do that, you'll make
They can
that.
hold
You'll
the
make
power,
that
bro.
podcast money.
Damn.
We won the feature product award at PRI. That's what that plaque is right there next to it.
Nice, man.
Yeah.
I'm over here. We're over here talking about LS. Screw that LS not playing.
Yeah.
Yeah, this is awesome.
Yeah. So they gave us a little accolade at the PRI show for bringing out that block.
Yeah.
yeah.
Are y'all like one of the first ones to have that block?
That is the only billet LT2 block that I know of by anybody.
Damn.
Yeah, so and again, it's kind of, we're trying to come up with these products. We know it's going to be needed, right? I mean, the C8 has a good following. It's a rear, mid-engine Corvette. So as soon as things get lined out with the power, with the rest of the tuning aspects of the thing, get the transmission lined out, all that, it's going to be one hell of a platform. And, having this where we're going to have that proven, done, ready to go, we'll have a 2,000 horsepower short block sitting on the shelf, ready to go. I think it's going to be the way to go.
The C8?
C8 Z06.
Oh, okay.
Yes.
Got you.
Yep.
So that's a whole different engine.
Then the C8 LT2. What's
LT2.
it? LT7. What is it, right? Or
LT6 or
LT6. It's got a 6-stage dry sump.
Why they skip numbers? Like I feel
don't
like they
know.
skip numbers.
Yeah.
Fucking Chevy.
LT6. So yeah, that's the flat plane. Naturally aspirated engine.
Damn.
And that one's, again, I mean, that's a killer. If you really look into the way that thing's built, I mean, it's got a lot of cool shit going on that. We haven't messed with any of those yet. We've got a couple guys that are claiming they're bringing one by, but we'll see. I think it's all really comes down to the tuning aspect of it. If you can't properly tune the car, why kind of take it? I don't know. It's kind of like that's kind of it's a pretty special car.
Yeah.
But it's got a lot of cool things going on with it. There's the manifold on that thing. It's pretty ridiculous.
No wonder why they cost like 180.
Yeah. No shit. Yeah.
No, I'm serious.
That's the closest thing to a true race engine that has been available in a production car from GM by far. I mean, that
Really?
engine is a serious piece for sure.
And I'm guessing that's the one that can rev up like crazy, right?
Yes.
Damn.
Yeah.
So you haven't touched it, you said, right?
No.
No.
I mess with it.
Damn. So this one right here, you said it can hold up to like 3,000?
Mm-hmm.
That's crazy, man.
Heck yeah.
So assembled and everything, what would it cost for this one?
I mean, when you start getting into and again, it all depends on how crazy a valve train you're going. So,
Well, you said 3,000.
yeah, like something like that is going to be in that 60,000 range.
Okay.
Yeah, you'll have about 60 grand in a motor.
Nice.
Yep. That's where it's at right there. I mean, it's got a lot of machine hours in it. There's a lot of time invested, you know what I mean?
Yeah.
It's a ton of time that needs to be put in to create something. Not only the block, you know, but I mean, you got probably 26, 27 hours of machine work at least in the engine block before it goes to the normal machining process, right? Then you start just your normal, you know, honing of the block and, you know, tuning up the line hone and getting everything right. So like the machine work, the traditional machine work starts after, you know, 20, 30 hours of block machine work.
And you were mentioning the flat plane crank before. Mm-hmm. What would be the difference on that than this style? So what would this style be called? Cross plane?
Yeah, it's just it's like this would be your typical 90-degree V8.
And then
of course to the bank, but the flat plane it's all the flat plane or the cross plane is just in speaking of the architecture of the crankshaft itself.
And the way it's rotating, correct?
They rotate the same direction, but you it's in the firing order. In a flat plane crank inherently has some vibration issues and some. You really want a jack shaft, a balance shaft in a flat plane crank. GM, I mean, I can't speak for GM, but I think there's some inherent issues with a flat plane crank. I mean, it just sends hellacious vibrations at certain RPM ranges. You know, you have, you know, the waves that go through this thing, the oscillations and all that are ultimately detrimental to the engine itself.
Yeah.
So it's just not as smooth. You know, there's definitely people that make it work and all of that, but, you know, just not something that we've messed with a ton.
Yeah. Well, I feel like it's time to check out the shop, man.
Yeah.
And we can check it out, see what you got going on here. Yeah, so without further ado, thank you for tuning in to Go Hard Podcast. Make sure you check out LME. He's on Facebook, Instagram. You can check him out at latemodel.engines.com. If they want to order an engine, they can do it online or call.
Straight up, latemodel.engines.com or give us a shout, 713-849-4505. Be happy to help you.
If you want your LS LT, make sure you get it done right. Bring it to, you know, LME or just buy the block, the whole long block for it. Can get your heads, the intakes, pretty much everything you need. Your accessories, pretty much everything. You offer a lot of stuff, honestly.
Intake to oil pan, man. We got it covered.
Yeah, and then just give them a follow on, you know, the Instagram. They got a lot of new products coming. You heard it yourself. The Coyote motor is going to be awesome. Can't wait to see it. Can't wait to test it. Can't wait to see it blow up. Because I know one of these guys are going to push them to the limits, honestly. And that's part of testing, you know? That's part of testing. And
good luck.
Yeah. So, guys, thank you so much. Make sure you check out the full audio on Spotify, iTunes, you know, the shorts on TikTok, all the shorts on Instagram and YouTube. Anything else?
That's it, man. Appreciate you.
Thank you.
Thanks, bud.
Peace, guys.